Today, we're going to learn how we find the area of a trapezoid. A trapezoid is a type of quadrilateral, which means it has four sides. A trapezoid has one pair of parallel sides called bases. The other two sides are called the legs. There are three types of trapezoids. An isosceles trapezoid that has a pair of non-parallel sides that are equal in length and two pairs of congruent angles. The scalene trapezoid has no congruent angles or side lengths, and a right trapezoid has one pair of right angles. Before giving my students the formula for a trapezoid, I would give them a task to give them experience with the shape and finding the area. Our task is in charge of providing a slip and slide for field day. We need to know which area of field would give us the most room. There are three options. Which option would be the best, and how much material do we need to put down in order to make the slip and slide? Students would be given the three different trapezoids and a partner to work with. Their job would be to find the answer and to explain why. When looking at the isosceles trapezoid, I would hope that they would notice that it is composed of two triangles and one square in the center. Some students might also recognize that the trapezoid consists of two triangles. They may also notice that if they were to duplicate the first trapezoid and rotate it, it would create a parallelogram. When looking at the scalene trapezoid, I would hope that they could decompose it into two triangles of different sizes and a rectangle or square in the center. This trapezoid is decomposed into two triangles a different way. They may also notice that if they duplicate this trapezoid and flip it around, they also come up with another parallelogram. Finally, with the right trapezoid, they would notice that they've got a right angle, which creates a square, and then a triangle that comes off of it when they decompose it. This is another example of how they could decompose the trapezoid into two triangles. When they duplicate this trapezoid and rotate and put it next to the other, it becomes a rectangle. Students could use a variety of strategies to find the area of each trapezoid. After some time, I would have pairs share with each other to see and compare what their answers were while explaining their reasoning. I would then introduce the formula A equals half the height times A plus B. I would explain that A and B are always our base or parallel sides, no matter which way that the trapezoid is facing. To begin, we need to find the units that each trapezoid is composed of. So let's start on this first trapezoid. The top base is worth 6. Now, when we count these units, we're not counting the squares. It's more like a number line. We're counting from each line to the next. So we've got 6 for the top base, 10 for the bottom base, and then we're going to identify the height, and that's what is in between the two bases. So we've got 9 units there. So we're going to plug that into our equation. So we've got half of 9 times 6 plus 10. So that gives us 4.5 times 16, which equals 72 square units. Our next trapezoid let's go ahead and we'll count on this one as well. Our first base is 5. Our second base is 12. And the height of this one is 10. So when we create the equation, we get half of 10 times 5 plus 12. So when we simplify that, we've got 5 times 17, which gives us 85 square units. Now, this last one, the trapezoid has been rotated just a little bit, and so it looks different, but we do it the same way. We're going to look at our bases, so those two parallel lines, and our first one is 6, our next one is 11, and then we've got to find the height. Now, this might trick us just a little bit because a lot of times when we look at height, we look at how tall something is, but that h is going to equal the units between your bases. And so when we count those, we get 10. So our simplified equation is A equals 5 times 17, which gives us 85 square units. This formula works because if we split the trapezoid into two triangles by drawing a diagonal line, triangle 1 has a base of line A and a height of h, which equals 1/2 of AH. Triangle 2 is upside down, but has a base of line B and a height of h, which is the same as the other one, which equals 1/2 of BH. So to find the area of the trapezoid, we add the areas of both triangles, 1/2 of AH plus 1/2 of BH. When we simplify that, it gives us 1/2 of H times A plus B. Now, returning to our task, the students would likely choose the second or the third trapezoid to be able to do our slip and slide on. Both of them equal 85 square units, so they are the larger areas. They would just have to decide which one would be more conducive to an awesome slip and slide for their field day.